Welcome to day 1, which is section 1, graphing quadratic functions. We're going to do 2 objectives today. We are going to graph quadratic functions in standard form, and we're going to graph and interpret minimum and maximum values. So starting with, well, what exactly is a quadratic function? A quadratic function is a function where the highest power is 2. Now, before we started, I forgot to point out this figure in the left. Now, it does say no calculator. The majority of what we're going to be doing is no calculator, but you will be allowed to use a calculator for the end part. So do keep it out, but just put it to the side. The equation for a quadratic function is y equals ax squared plus bx plus c. This is called standard form. So you're going to see quadratics in other forms as well, but today we're just going to be talking about standard form. So today we're going to be graphing quadratics, which is the picture that you see to your right. So the graph looks like a parabola. That just means a U. So if you'll notice that blue U to the right, that's the parabola. The axis of symmetry is this red line that goes through the middle. And what it does is it cuts the parabola into 2 symmetric parts. So the 2 parts are going to be mirror images of each other. And then you're going to be finding what's called the vertex. So vertex is this point right here. It's always either the maximum or the minimum. It's kind of where the graph starts. So let's just jump in with example number 1. On the left, you're going to find steps, and on the right, you're going to see an example. So the first step for you to do is always to find the vertex. The vertex is x equals negative b over 2a. So your vertex is going to be some point that negative b over 2a would give you the x. So looking at our example to the right, I have f of x equals x squared plus 4x minus 3. So in this case, our a is 1, it's in front of the x squared. Our b is 4, it's in front of the x, and our c is negative 3. So to find our vertex, I do negative b, so negative 4 over 2 times a. Negative 4 divided by 2 is going to be negative 2. So my vertex is going to be negative 2, comma, some number. Now to find that y value, I have to substitute negative 2 into my equation. So I have negative 2 squared plus 4 times negative 2 minus 3. So this is 4 minus 8 minus 3. 4 minus 8 is negative 4. Negative 4 minus 3 is going to be negative 7. So my vertex is negative 2, comma, negative 7. Now, second part is we're going to find the equation for the axis of symmetry. That's going to be x equals negative b over 2a again. But what you're going to notice is this is an equation this time. It's not a point. So we already did our negative b over 2a and we got negative 2. So our axis of symmetry is negative 2. Now the y-intercept is where x is 0. So that just means substitute in a 0 for x. So looking at our equation, we get 0 squared plus 4 times 0 minus 3, which is just negative 3. So our y-intercept is 0, comma, negative 3. Lastly, we're going to graph. So your parabola, if we look to the left, is either going to go up or it's going to go down. Your parabola will go up when a is positive. When a is negative, your parabola is going to go down. So in our example, our a value is 1, it's positive, so our parabola is going to be opening up. Lastly, we need to draw in a table. The vertex will always go in the middle, so that's negative 2, negative 7. So this should remind you a little bit of when you graphed absolute value, which was the v. Now you're going to go down 2 values, so negative 3 and negative 4, and up to negative 1 and 0. Now 0 I already did, that's negative 3. So now I have 3 different x values that I need to substitute in order to find y. Now I didn't give you a whole lot of room for this. I really didn't give you any room for this, so let's do our best. If we substitute in negative 1, I get negative 1 squared plus 4 times negative 1 minus 3. This is 1 plus negative 4 plus negative 3, which is negative 6. Okay, I'm going to erase that so that I can substitute in my negative 3 and my negative 4. If I substitute in negative 3, I get negative 3 squared plus 4 times negative 3 minus 3. This is 9, add negative 12 minus 3. That's going to give me negative 6 again. Okay, now here's what you should notice. These two values were the same. That should be the case with a parabola. A parabola is symmetric. That means these two values are also going to be the same. So this is going to be negative 3. Now we're ready to graph. First, you're always going to graph the axis of symmetry. That's a line. I'm going to do it as dotted though. So this is going to go at negative 2. So here's your axis of symmetry. Our vertex is at negative 2, negative 7, which is right here. And then I have negative 1, negative 6, and 0, negative 3. I have negative 3, negative 6, and negative 4, negative 3. And then you connect. So remember that you should have a parabola. You should have this U shape. It should be symmetric, so the axis of symmetry should cut through the middle. And in our case, when A is 1, it opened up. So yes, there's a lot of steps to this. And no, you are not allowed to use a calculator. So let's try to do this again on the next page. Okay, so let's try this next example, example number 2. Starting out with the vertex. Remember that the vertex is negative b over 2a. Our a in this case is negative 2, it's in front of the x squared. Our b is negative 4, it's in front of the x. And our c is positive 6. So opposite of b is going to be positive 4. And then I have 2 times negative 2. This ends up being 4 divided by negative 4. So I get x equals negative 1. Now to find my y, I need to substitute this negative 1 back in. So I get negative 2 times negative 1 squared minus 4 times negative 1 plus 6. So negative 1 squared is just positive 1. Negative 4 and negative 1 is positive 4 and positive 6. So this ends up being negative 2 plus 4 plus 6, which is 8. So my vertex is negative 1 comma 8. Now for the axis of symmetry, remember that this goes through the vertex. It's just the x coordinate of the vertex, which is x equals negative 1. Now my y-intercept happens when I substitute in 0 for x. So I get negative 2 times 0 squared minus 4 times 0 plus 6. What you're going to notice every time is that it's just c. The a and the b term go away when you substitute in the 0. So my y-intercept is 0, 6. Lastly is my table of values. The middle of your table is always your vertex, so negative 1, 8, and I'm going to put a box around it. Go down 2, so negative 2 and negative 3, and up 2, so 0 and 1. Now I already know that my y-intercept is 0, 6, so now I just have 3 values to substitute in. I'm going to start with 1. So I have negative 2 times 1 squared minus 4 times 1 plus 6. So this is negative 2 minus 4 plus 6, which is negative 6 plus 6, which is 0. So 1, 0 is a point. Now, I know that my parabola is going to be symmetric. So when I substitute in negative 2, I should get 6. But let's make sure that I do. Okay, so negative 2 squared is 4. So this is negative 2 times 4. Negative 4 and negative 2 is positive 8. So negative 2 times 4 is negative 8. I have negative 8 plus 6, which is just 6. Now, I again know that the negative 3 and the 1 are going to be symmetric, so when I substitute in negative 3, I'm going to get 0. Now, it's a good idea to substitute that negative 3 in anyway just to check your work, because you know that if you substitute in negative 3 and you don't get a 0, then you made a mistake somewhere. Now we are ready to graph. We're going to start with the axis of symmetry, so that's at x equals negative 1. My vertex is at negative 1, 8, which is up here. And then I have 0, 6, and negative 2, 6. And then 1, 0, and negative 3, 0. Okay, just as a mental check, my parabola is opening down. Does that make sense? Well, my a value was negative. I had a negative 2x squared. That means the parabola should open down. Lastly, we have to do the domain and range. Now, domain, remember, is what your x values can be. And your range is what your y values can be. If I start at the origin, x is left, right. As I go left, my graph continues indefinitely in the negative direction. It also continues indefinitely in the positive direction. So my domain is all real numbers. X can take on any value that it wants. Now my range is for y. If I start at the origin and I go up, I notice that the graph stops when y equals 8. 8 is the highest that y can take on. From there, y decreases. So my range is y is less than or equal to 8. 8 is the maximum that it can be. Okay, next example is one for you to do on your own. Right now, I would like you to pause the video and try example 3 on your own. Please do not use a calculator. Come back when you are finished. Okay, let's see how we did. First thing that you should have done is found the vertex. In this case, your a is negative 1. It's what's in front of the b. In front of the x squared. Your b is 0 and your c is 4. So hopefully you knew that b was 0. B is 0 because there's no x term. Okay, so our vertex is negative b over 2a, which is 0 over negative 2. So our x is 0. Now we have to substitute that in to find y. So I get negative 0 squared plus 4, which is just 4. So your vertex should have been 0, 4. If you didn't get 0 or you didn't get 0, 4, that would have messed up the rest of your graph. Axis of symmetry goes with the vertex, so that's just x equals 0. Your y-intercept happens when you substitute in 0 for x. Well, your y-intercept and your vertex in this case end up being the same. They're both 0, 4. And then you should have done your table. Remember that 0, 4 goes in the middle. I'm going to choose two values smaller, so negative 1 and negative 2, and two bigger, 1 and 2. And then we should have substituted in. Now, it's kind of tricky here to substitute. So you have negative x squared plus 4. By order of operations, I want to do the squaring in first and then the negative. So when I substitute in 1, it's going to be negative 1 squared plus 4. 1 squared is 1, so it's negative 1 plus 4, which is 3. When I substitute in 2, it's negative 2 squared plus 4, which is negative 4 plus 4, so that's 0. I'm going to substitute in negative 2 and negative 1 just to check my answers. It's true that you don't have to. We know what they're going to end up being, but it's always just good just to check. When I substitute in negative 1, I get negative 1 squared plus 4. Negative 1 squared is 1. That negative comes down though. Negative 1 plus 4 is going to be 3. And then I have a negative 2 squared plus 4. This ends up being negative 4 plus 4, which is 0. Remember, by the symmetry of a parabola, these should be the same. And now we're ready to graph. The first part that I'm going to graph is the axis of symmetry. In this case, which is just our y-axis. So our vertex is 0, 4, right up here. And then I have 1, 3, and negative 1, 3, and 2, 0, and negative 2, 0. Okay, I always like to ask myself, does this make sense? Does it make sense that my parabola is opening down? Well, I have a negative a value. I have a negative x squared, so it should be opening down. Lastly, you should have done the domain and range. Your domain is all real numbers. x can take on any value. It goes indefinitely in the negative direction, it goes indefinitely in the positive direction. There's no walls for the x. For the range, the highest value that y takes on is 4, and it gets smaller. So you have y is less than or equal to 4. 4 is the ceiling, but then there's no floor. So hopefully that went well for you, but again, like I said, if you found the vertex wrong, it would have messed up the rest of the problem. So that's graphing. Right now, we're going to switch gears a little bit, but kind of stay within graphing. Okay, right now, we're going to find what's called the minimum and the maximum values. So when that a value is positive, when it's greater than 0, the graph opens up. If it opens up, it has a minimum value. So it has a lowest point. When a is less than 0, the graph opens down. And has a maximum value. So that's what you're going to be doing right now. Is I'm going to give you a quadratic, and you're going to tell me whether it has a minimum or a maximum, and find that. So looking at example number 4, we have negative 4x plus 12x plus 18. So in this case, negative 4 means I'm opening down. If I'm opening down, my parabola is going to be something like this, so I'm going to have a maximum value. Okay, that minimum or that maximum value happens at the vertex, so you're going to have to find the vertex. So negative b in this case is negative 12 over 2 times negative 4. So this is negative 12 over negative 8. If I divide both by negative 4, this is 3 over 2. Okay, that's not the minimum or the maximum value. That's where the minimum or the maximum happens. Now I need to substitute 3 over 2 in. So I'm going to have negative 4 times 3 over 2 squared plus 12 times 3 over 2 plus 18. In this case, you might need a calculator. The ones I give you in class will not be such large numbers, so you won't need a calculator. But that simplifies to be 27. So now you're going to say the maximum is 27 at x equals 3 over 2. Lastly, stating the domain and range. Your domain is going to be all real numbers. So again, your x value can take on anything at once. It goes indefinitely in both the positive and the negative direction. For the range, we know that 27 is our maximum, which means that the graph goes down from there. So our range is going to be y is less than or equal to 27. Example number 5, I would like you to try on your own. That's what the stop sign means. So pause the video, try this one on your own, and come back when you are finished, please. Okay, let's see how we did. First thing that you should have noticed is that you have a positive 4x squared in this case, so your parabola is going to open up. If I have a parabola that opens up, I'm going to have a minimum value. Next, you should have actually found that value. So x is negative b, which in this case is negative 24, so positive 24, over 2a over 2 times 4. 24 divided by 8 is 3. Now this one you should have been able to substitute in yourself. You shouldn't have used a calculator. So I have 4 times 3 squared minus 24 times 3 plus 11. 3 squared is 9. 9 times 4 is 36. 24 times 3 is 72 plus 11. 36 minus 72 is negative 36. Negative 36 add 11 is negative 25. So then you should have said the minimum is negative 25 at x equals 3. Lastly, for domain and range. Your domain, again, should have been all real numbers. There are no restrictions on x in a quadratic function. X can be whatever it wants. Okay, your range, hopefully you thought about this and didn't just look at the previous example. I have a minimum, which means my graph is opening up, so y is getting bigger. So y is going to be greater than or equal to negative 25 in this case. So if you got that one, great. If you got that one right, great. If not, that's okay. We're going to have some more practice tomorrow. If you would please move the page. So now we're going to move on to doing the same thing, but on a calculator. So looking at example number 6, it says find the minimum or the maximum value. Now you could do this exactly the way that we just did, by noticing that this is going to open up, and then it has a minimum, and then by finding the vertex. What I'm going to do right now is show you how to do this on the calculator though. So right now we're going to do this on the calculator. As we go through the example together, we're going to write down the steps to the left. So get out your calculator, please. So I'm going to do this problem along with you, so I want you to follow along. The first thing that I want you to do is to go to y equals. If there's any equation in there, clear it out and enter in the equation we have. We have 12x squared minus 21x plus 8. Remember that there's an x button. Then you're going to hit zoom and go down to number 6, which is zoom standard. So this is the graph that you should be looking at. Okay, does this make sense? Well, first of all, we have positive 12x squared. So yes, it makes sense that our parabola is opening up. Now, we need to think, am I finding a minimum or a maximum? Well, if it's opening up, then I want the minimum. So the next thing that you're going to do is hit second calc. And you're going to notice options 3 and 4 are minimum and maximum. In this case, we're finding a minimum, so go down and choose minimum. It's asking you for the left bound, so I want you to scroll until you're near that minimum. Left bound means the left boundary. So what you're going to do is you're going to hit left a few times and then hit enter. Now go back to that vertex. This time it's asking for the right bound. And what I'm saying is down in that bottom left of the calculator screen, that's where it says left bound and right bound. When it says right bound, hit right a few times and hit enter. Then the calculator says, do you want me to guess? So you're going to hit enter again. And this is the value that you should get. So you should find that your minimum is negative 1.1875 at x equals 0.875. And that's your answer. Now, if I went through that too quickly, please make sure that you go back and you redo that. What I want to do right now is make sure that we have those steps down. So the first step is that you enter your equation in y equals. Then you're going to hit zoom 6, which is zoom standard. Then you're going to go to second, calculate, and you're either going to choose minimum or maximum. In this case, we are calculating a minimum. Then you're going to find the left bound and hit enter. You're going to find the right bound and hit enter. And you're going to hit enter for your guess. Again, which is just telling the calculator that you want the calculator to guess at what the value is. And that's it. So that's not too bad. Let's go down and look at the next example. So here's our example number 7. Again, we're going to do this in the calculator. So if you would take out your calculator right now and enter this into y equals, please. Okay, so that's what I've done right here. I went to y equals and I entered in my equation. Now you're going to go zoom and hit number 6 so that we can see our parabola. Now ask yourselves, first of all, does this make sense? Well, yes, I have a negative 8.3x squared, a negative value in front of the x squared, so it's going to open down. And then, am I going to find a minimum or a maximum? Well, if it's opening down, we have a maximum value. So next, hit second calculate, and go down to maximum. Hit enter. Now I want you to scroll towards that maximum. Okay, so the calculator in the bottom left screen is asking you for the left bound or the left boundary. So that means hit left a few times and then hit enter. Now go back to that maximum. This time the right boundary, hit right a few times, hit enter. Hit enter one more time to guess, and there's your maximum. So we would say our maximum, again, is the y value, so it's negative 0.0964 at x equals 0.8434. One thing I want to point out is your minimum or your maximum can be positive or negative. Before this example, all of our maximums were positive and all of our minimums were negative. That's not always the case. So here we have a maximum that's negative. So hopefully you have those calculator steps down because we're going to be doing a lot in the calculator. So if you have any questions, please make sure you bring them to class tomorrow and that you ask your teacher. We're almost done, I promise. If you would flip to the next page, please. Okay, here is the last problem, and this is the one that you're going to be doing. Today's video, we learned to graph, and then we found the minimum and the maximum, both by hand and on the calculator. But it all really circles around knowing how to graph in standard form. So here's the last example. This is one that you're going to do. We will check this when you come to class tomorrow. If you need any help, make sure you go back previously and look in the video, or that you check your notes. This should be done without a calculator. So good luck, and we'll see you tomorrow.